Today we will be studying the chapter Equation of a Straight Line. Now to explain how to get these equations formula, to begin with I have drawn the axis x-axis and the y-axis, and then I have drawn these two lines cutting the x-axis at point A and the y-axis at point B, and then drawn another line cutting the x-axis at P and the y-axis at Q. Now we need to know the angle which these lines make with the x-axis. So if I take a look at this line, there are two angles made, one which I have marked as theta and the one adjacent to it, this one. But this theta angle is always to be taken as the angle between the line and the positive side of the x-axis. So that's why this angle we cannot take. Similarly, if I take a look at this line, then the angle theta will be marked as the angle between this line and the positive side of the x-axis. So I cannot take this angle. So in this case this theta is acute, but in this case it is obtuse. And this theta is called as inclination. Then next I come to a term which is m, standing for the slope of the line. This slope of the line is also called as gradient, and we get the value of this m by finding tan of this angle. So tan of these angles will give us the slope of the line. Then these lines are cutting the x-axis and y-axis. So here at this place the first line is cutting the x-axis at A. So this length OA will be called as x-intercept. And same way for the second line, OP is the x-intercept. So I have written here OP or OA is called as the x-intercept. Same way these two lines are cutting the y-axis also. So first line is cutting the y-axis at B and second at Q. Now O to A will be y-axis, will be y-intercept. Same way O to Q also will be y-intercept. So I have written here OQ or OB is your y-intercept, and this y-intercept we call it as, we take this length as C. This is the symbol by which we will be using that, knowing that y-intercept. Now we will see how to get the equation of different types of lines. So first of all we will begin with a line which is parallel to the x-axis. So I have drawn a line here which is parallel to the x-axis at a distance of B. What it means is that if I will take any point on this line, its y value will always come as B because it is at a distance of B. But x value will be changing. So we will know the equation of this line as equation of a line parallel to x-axis will be y equals to B. So for example, if it is passing through a point here where it is marked as 4, so the equation of this line will be y equals to 4. Next we look at a line which is parallel to the y-axis. So this is the y-axis and this is the line drawn parallel to the y-axis, and it is at a distance A from the y-axis. So if I take any point on this line, its x value will always remain as A, but y value will change. So any such line which is parallel to the y-axis will have the equation, that is equation of a line parallel to y-axis will be x equals to A. Like for example, if this line is passing here through the point where x has a value here 5, so this line will have an equation as x equals to 5. Now we will see how to find the equation of a line which is not parallel to any of these x-axis or the y-axis. So it is an oblique line. So this is an oblique line drawn which is meeting the x-axis at A, y-axis at B, and it is passing through a point which has coordinate as x comma y. So if this point P has a coordinate x comma y, it means from here to here is x value, and at the same height from here to here will be y. So I have written this will be y, and this y-intercept is C. So this will be C, so I will be getting this length as y minus C, and this is equal to this, so this will be x. Now this is the angle theta, which is the inclination. So this angle will be equal to this angle because of corresponding angles are equal. Now in this triangle, if I find the tan of this angle, which is called as the slope. So I am writing here m is equals to tan theta, that is the slope is equal to tan theta, and tan theta from here, as you know, is perpendicular by base, so I will get Pn by Bn. Now this value Pn is y minus c, and this m is copied and Bn is x. So now cross multiplied, I will get mx equals to y minus c, and then minus c taken that side, so I will get y equals to mx plus c. Now in this case, to use this equation to find the equation of a line, y and x will be as it is. We need to know the value of the slope and the y-intercept. So this equation is given a name as slope-intercept form, and we write it as y equals to mx plus c. So if I have to make this formula for making an equation of a straight line, I should be knowing the value of the slope and the y-intercept. Now we will see another formula for finding the equation of a straight line. That same straight line has a point Q whose coordinate is written as x1, y1. So Q lies on this line. So now if I have to make use of the coordinate of this point to get the equation of a straight line, so what will be the formula becoming as? So already we know that the equation of this straight line is y equals to mx plus c. So now since point Q lies on this line, so I have written since Q x1 y1 passes through the above line, so in place of y I can write y1, and in place of x I can write x1. So I get here y1 equals to mx1 plus c. And now I subtract both these two equations, equation 1 minus equation 2. So I get y minus y1, and then mx minus mx1, and plus c and minus c then will get cancelled. So then I take m common from here, so I get y minus y1 equals to mx minus x1. So you can see in the formula there is no more c here. So without knowing the y-intercept, just knowing the coordinate of this point, that is the point which is lying on the line, and the slope of the line, I can get the equation made. And so that equation, we remember it in this way, point slope form. So y minus y1 equals to mx minus x1. So I need to know the coordinate, the value of x1 and y1. Y and x will remain as it is in the equation. Now we will see if we have 2 points lying on a line and both of their coordinates are known. So what formula we are going to get to find the equation of that line? So I have taken another point apart from Q x1 y1, that is R x2 y2. So I will be knowing the coordinate of these 2 points, and then I have to get the equation of this line. So already we knew that this line has this formula y minus y1 equals to mx minus x1. Now since this point R x2 y2 is passing through this above line, so in place of y I can put y2, and in place of x I can put x2, and so I get y2 minus y1 equals to mx2 minus x1. So if I bring x2 minus x1 to the other side, I get the value of slope m as y2 minus y1 by x2 minus x1, and this will be a very important formula for finding the slope when 2 points are known. Now since I know this value of m, I can put it back in that equation 1. So I will get y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. And this is my formula for finding the equation of a straight line when I know the coordinates of 2 points lying on that line. And this can be written in another simplified form in this way, that is y minus y1 by this y2 minus y1 taken this side, so y2 minus y1 equals to x minus x1 by x2 minus x1. And remembering this formula in this way is easier, because once you remember of one side, the other side is exactly in the same pattern, and one side is all x values and the other side we have it of y value. So knowing all these formulas, and we will be doing the coming exercise by applying all these formulas. Thank you.